Glycolysis is the process that the cell uses to generate energy anaerobically. So it uses glucose to make a net of two molecules of ATP. And the mnemonic we're going to use to memorize this is hungry pirates pick all the greatest pickled pumpkins ever picked. So each capital letter stands for an enzyme. So the first enzyme is hexokinase. The second enzyme is P, so phosphoglucose isomerase. And because there are a lot of P enzymes in here, I made sure that every mnemonic word corresponded with whether it's a isomerase, a kinase, or a mutase. So pirates has an I, so it's phosphoglucose isomerase. And PIC has a K, so it's phosphofructose kinase. A, aldolase. The is triose phosphate isomerase. G, for greatest, is glyceraldehyde 3P dehydrogenase. Pickled, P, it has a K in there, so it's phosphoglycerate kinase. Pumpkins has an M, so it's phosphoglycerate mutase. E, enolase, and picked has another K, so that's pyruvate kinase. So let's go over these enzymes one more time. So we have hexokinase, phosphoglucose isomerase, phosphofructose kinase 1, aldolase, triose phosphate isomerase, glyceraldehyde 3-phosphate dehydrogenase, phosphoglycerate kinase, phosphoglyceromutase, enolase, and pyruvate kinase. The important enzymes to remember in here are the first one, the third one, the seventh one, and the 10th one. So the first one is hexokinase. The third one is phosphofructokinase 1. Seventh one is phosphoglycerate kinase, and the 10th one is pyruvate kinase. All of these have to do with ATP. So the first two are converting ATP to ADP. So they're using energy. The second two are converting ADP to ATP. So they're gaining energy. The first two subtract 2 ATP, and the second two add 4 for a net of 2 ATP molecules gained. So once again, it's 1, 3, 7, and 10. These are all the important enzymes to remember. And you can remember this by the equation 3 plus 7 equals 10. And there's a 1 in there. So 1, 3, 7, 10. Okay, now I'm going to draw it out for you guys. So we're going to start with glucose. So glucose is a 6-carbon, 6-membered ring. But one of the members of those rings is oxygen. One of those carbons is hanging out here, and it has an OH attached. Then it actually has an OH attached to every other carbon except for the 5th carbon. And that is converted by hexokinase into glucose 6-phosphate. So that 6 carbon that's hanging out there, that has a inorganic phosphate attached to it. And then it still has all these OH groups hanging off of it too. Then you have phosphoglucose isomerase, which changes it from a glucose molecule to a fructose molecule. So instead of it being a 6-membered ring, it's now a 5-membered ring. You still have that carbon and phosphate hanging off there, but now you have another carbon hanging off there too. Because you didn't remove any carbons, you just changed the ring structure from 6 to 5. And then you have phosphofructokinase 1. So it's taking that phosphofructose and it's going to be adding another phosphate group onto there. So we had that original phosphate, and then we're going to be adding another one. And then, of course, it still has all those OHs hanging off. So the enzyme aldolase splits up the molecule fructose 1,6-biphosphate into dihydroxyacetone phosphate and glyceraldehyde 3-phosphate. So the one up here is dihydroxyacetone phosphate. It's a ketone group with a phosphate group on the left and the OH group on the right. And down here we have the glyceraldehyde 3-phosphate. So it's a aldehyde group. So it's double bond O and an H hanging off of that carbon. And in the middle we have OH, and on the left we have phosphate. And the ketone is converted to the aldehyde using triose phosphate isomerase. And then glyceraldehyde 3-phosphate is converted to 1,3-biphosphoglycerate using the enzyme glyceraldehyde 3-phosphate dehydrogenase. And 1,3-biphosphoglycerate looks like this. It has a phosphate group on the right, an OH group in the middle, and another phosphate group on the left. That is converted using the enzyme phosphoglycerate kinase into 3-phosphoglycerate. Then that is converted using the enzyme phosphoglyceromutase into 2-phosphoglycerate. So you can see the phosphate group has moved from the left and it's now in the middle. So it's mutating. Nothing's really changed, it's just those groups have moved around, or they switch places. And so 2-phosphoglycerate is converted using the enzyme enolase into phosphoenol pyruvate. So it has that enol group, which is the double bonded carbon, and it has that phosphate group hanging off the bottom. Then that's converted using pyruvate kinase into pyruvate. So this is kind of a cluttered mess. So we kind of need a better way to draw out this that will be easier to remember and easier to draw. So let's try this again. Let's draw out 4 circles, a W and an M, and then 3 more M's, and then 2 lightning bolts. This is going to make sense pretty soon. So in the first 2 circles, you're going to draw an arm, and on the second one, you're going to draw a phosphate group because it's being charged through hexokinase. Then you've got 2 arms because it's a fructose now, and phosphofructokinase 1 charges that second arm with another phosphate. Aldolase splits it up into 2, a ketone and an aldehyde group. And that ketone is converted to the aldehyde using triose phosphate isomerase. So down here, with the 3 M's and the 2 lightning bolts, we know that they all have carbonyl groups on that rightmost carbon. So let's just draw them all in. And let's just draw in the enzymes too. So we have G, P, P, E, P. So on this first M, we have 2 phosphate groups because glyceraldehyde 3-phosphate dehydrogenase charges it with a phosphate group. And then let's just fill out these enzymes. So we have PK, PM, and another PK over here. PK removes one of the phosphate groups, and PM, if you can remember, mutates it. So the phosphate group on the left is now in the middle. Then you have enolase, which is the enol group, and the phosphate's still there. And then you have PK, which removes that last phosphate group. Okay, now for good measure, let's try it all once more. So first you have glucose, and that's converted by hexokinase to add a phosphate group there. That's converted by phosphoglucose isomerase to make it fructose. That's converted by phosphofructokinase 1 to add another phosphate group on there. That's split by aldolase to make a W and an M. One's a ketone, one's an aldehyde. And they have the phosphate groups on there. And then you have triose phosphate isomerase to convert one to the other. Then you have 3 M's down here and 2 lightning bolts. They're all carbonyl groups, so let's just draw those in. And let's draw on the enzymes too. And the one on the left has 2 phosphate groups. Then going forward, there's only one. It's mutated, and then it's an enol group, and then it's pyruvate. Okay, so just make sure you can draw this, and remember that the key reactions are 1, 3, 7, and 10. So the first 2, you use an ATP, and in the second 2, you gain 2. So you have a net of +2 ATP.